mathematicians. Today we're going to be talking about 4.3 in your packet, equivalent ratios and ratio tables. So make sure you have that ready. You're writing down the examples that I'm writing down, and then we'll be good to go. All right, so let's chat about equivalent ratios. What does that mean? Equivalent ratios are ratios that describe the same relationship. So for me, I think about baking or like Kool-Aid, right? When you're baking, it's kind of about if I have this much flour, I need this much sugar. So if I have the ratio of flour to sugar, okay, let's say you're baking brownies and it has 2 cups of flour and then 1 cup of sugar in the recipe. If I wanted to double that recipe, I wanted to multiply the 2 cups to make 2 recipes, I would have 4 cups of flour, but I want the amount of sugar, the relationships to stay the same, so I have to multiply this by 2 as well, right? So this is 1 recipe, and this is a double recipe, right? Or if you wanted to cut it in half, okay? If I didn't want to make the full thing of brownies, I don't know why I would want to do that, but it happens, right? Like, my family right now just has 2 people in it. Sometimes recipes I find online are made for like families of 8. That's a lot of extra food that I don't need, so I cut it in half or something like that. So I still want that relationship of flour to sugar to be the same, but I want to have half of it, so I'm going to divide it by 2. So 2 divided by 2 is 1, and we have 1/2 cup. So if you wanted a half recipe, those are the amounts of ingredients you'd want. But what's happening to one ingredient is happening to the other, so their proportion, how much they change by, is the same. Okay? So that's kind of what an equivalent ratio, that's what it is. That's when you would use it. Or if you've ever made Kool-Aid and you don't add the right amount of sugar, or you add too much water, it just throws the whole thing off. So you want them to stay, like, if I add this much of one thing, I always have to add this much of the other thing, okay? All right, so let's jump into the notes part. Okay, let me choose a pen. So I can use equivalent ratios. There we go. To fill ratio tables. Okay? So like I said, equivalent ratios are 2 different ratios, multiple ratios that describe the same relationship. So when I was talking about the ratio of flour to sugar, even though the amounts changed, it was still describing the same relationship of flour to sugar within that same recipe. Okay? So one way that we've seen equivalent ratios, equivalent means equal, describing the same thing, is when we reduced fractions. So if I have 12/15ths, remember that we can write ratios as a fraction. Okay, then I reduce that fraction by 3. Okay, just gotta get rid of my work. So 12/15ths and 4/5 are the same, right? They're equivalent because I reduced it. That's when we've seen it before. If I had the ratio 1 to 5, Well, let's say I want to multiply this by 4. Let's do a fun number. Let's do 7. 7 seems fun. Okay, so I'm multiplying each part by 7. Gives me 7 to 35. So that would be an equivalent ratio because as I multiplied each part of the ratio by the same amount, it was changing by the same amount. Another way you can find an equivalent ratio, let's do 2 to 9, okay? If I wanted to add 2 more on that side, I have to add 9 more on the other side, right? Because every time I add 2, I have to add 9 to keep it the same. So those would be equivalent ratios. So I wanted to add 1 more of this ratio. Goodness, right? So that's how we got to that. You know, and these can be kind of tricky because there's multiple ways to do it. You can do it by adding and you can do it by multiplying. So it's kind of up to you to figure out what is the best way to figure out which one is equivalent. Okay? So on this guy, it says circle the ratios that are equivalent to 1 to 3. Okay. So to get from 1 to 2, I multiply by 2, which gives me 2. Then I have to multiply the other side by the same thing, 2. There we go. Okay, so 1 times 2 is 2, and 3 times 2 is 6. So since that worked out, 2 to 6 is an equivalent ratio. Because I could multiply by both things on the same side, or on each side, and it got me one of those, okay? Let's try 3 to 3, okay? 1 times 3 is 3, but then I have to multiply the other side by 3, which would be 3 to 9. And that is not this one, so I don't get to circle 3 to 3. Okay. Same thing, 1 times 3 is 3, but 3 times 3 is 9. 3 to 1, not the same, right? I could multiply one side, but when I multiplied by the other side, it made it something different. Okay. Let's try comparing it 1 to 3 to the ratio 4 to 12. So I'm going to say, how do I get from 1 to 4? Well, I'm going to multiply by 4. 1 times 4 is 4. Then I have to multiply the other side of my ratio by 4, so times 4. 3 times 4 is 12. Oh, those are the same. When I multiplied both sides by the same number, it got the other ratio, so I get to circle that one. Those ones are equivalent. Okay. Let's try 10 to 30. To get from 1 to 10, multiply by 10. I think the easiest way is to multiply. So we're going to multiply both sides by 10. 1 times 10 is 10. And 3 times 10 is 30. So since I took that first ratio, 1 to 3, I could multiply it on both sides by the same thing and get the other ratio, they are equivalent. Okay. Okay. All right, 1 to 5, we're going to multiply by 5. So 1 times 5 is 5. Then I have to multiply the other side by 5. 3 times 5 is 15. That matches, so we get to circle it. Sorry, I got the hiccups all of a sudden. Okay. Then from 1 to 8, we're going to multiply by 8. 3 times 8 is 24. Okay, so I multiplied my original ratio 1 to 3 by the same thing on both sides, but I didn't get the other ratio out of it, so it doesn't work. Alright, last one. Okay, from 1 to 58, we would multiply by 58. And then when I do 3 times 58, you get 174. Which that is not 48, right? So that one is not an equivalent ratio. Okay. Okay. So write 2 different ratios that are equivalent to 1 to 7. So one way I'm going to do it is I'm going to multiply by 2, right? You can multiply by anything on both sides. So 1 times 2 is 2, and 7 times 2 is 14. Okay. You can also do it by dividing. Let's divide by 3. Okay, so we're going to have 1 divided by 3, and then 7 divided by 3, which just end up being fractions. So 1 to 7 to produce an equivalent ratio would be 2 to 14. Another equivalent one would be 1/3 to 7/3, okay? So as long as you're changing both sides by the same amount, it's equivalent, okay? Okay, let's chat about ratio tables. A ratio table is a table that contains equivalent ratios. So this table is all going to describe the same relationship. It's always changing by the same amount, okay? So here we have the number of trees and then the number of apples. So for every 1 tree, you get 17 apples, okay? And this is kind of where it can get tricky. I can do this by multiplying. I can also do it by adding. So to get from 1 to 2 trees, I added 1 tree. Then from 17 to 34, I added 17. So for every 1 you add, you have to add 17. I can't show that on my fingers, okay? So from 2 to 3, I added 1, which means for the number of apples, I have to add 17. Okay, which is 51. Okay, from 3 to 5, I'm adding 2. So that means I have to add 2 sets of 17. So I have to add 17 plus 17, okay, which is 34. Okay, so on that bottom row, we add 34, right, because we added 2 sets, so I have to add 17 and then 17, which is the total of 34. Help if I turned my pen back on. Okay, so to get from 3 to 5, goodness, that's not going to let me erase, is it? So 51 plus 34 is 85. Okay, let's turn my light back on. There we go, it's a little brighter now. Okay, so same thing. Ooh, it does not like me to erase. How fun is that? Silly iPad. Why would it ever be easy? Okay, but basically, then again, from 5 to 7, I'm adding 2. So I'm adding 1 plus 1. So on the bottom, I have to keep my ratio the same and add 17 plus 17, which is 34 again. Okay, so 85 plus 34 is 119. Okay. So you have to keep how much you're adding the same. So whatever you add on top, the ratio on the bottom, you have to add the ratios together. Okay? Okay, so I'm going to show you how to do the second table using equivalent ratios. So one with the apples, we did it by adding, so I'm going to show you another way to do it. First of all, this should say the ratio of miles to hours. Okay? I copied and pasted. I didn't fix it. Happens all the time. Okay? So with equivalent ratios, I'm going to take one of the ratios. So we're going to take, let's take 70 to 2. Okay? So to fill in this one, I have a blank, or I have 35 miles to I don't know how many hours. So I'm going to use equivalent ratios to figure out their relationship. I do not know why this won't let me erase. What in the world? So silly. Okay. So basically, to get from 70 to 35, I'm going to divide by 2. Right? And you might have to use a calculator to play around with that. So I took 70 divided by 35 was 2. Okay. So that means on the other side, I have to divide by 2 as well. And 2 divided by 2 is 1. Okay, so that gives me the ratio 35 miles in 1 hour. That's where we get 35 miles per hour. Ooh, fancy, okay? Okay, I'm going to use that ratio since it has the 1. That's a little easier for me to work with. So I'm going to use that to fill in the rest. Okay. So I have 35 miles to 1 hour. Then I have 105 miles to I don't know how many hours. Okay? So I'm going to take a calculator. Handy dandy. Shows it backwards for you, but that's okay. Okay, so basically to figure out the relationship, I'm going to take 105 divided by 35, which is 3. Okay, so that means that 35 times 3 is 105. And I'm going to double check that. 35 times 3. I got 105. It's backwards, but you can see it. Okay. So that means I need to take the other side times 3. Okay, so you can go 105 miles in 3 hours. Okay, scooch him over. Okay, and I'm going to use that same ratio, 35 miles to 1 hour. Except this time, I want to know how many miles in 8.5 hours, okay? So by multiplying to get from 1 to 8.5, multiply by 8.5, okay? So on the other side, I have to multiply by 8.5. So we're going to take 35 times 8.5. Is 297.5. Okay. So if you use a ratio and then use equivalent ratios, because sometimes the pattern isn't always obvious what we're adding. Right? Like here I was adding 1, here I was adding 1. But from 3 to 7, I added 4. From 7 to 8.5, I added 1.5. So for me, it was easier to use the ratios and kind of do the multiplication that way. So ratio tables can be kind of tricky because you can do it by adding, or if you're going backwards, you'd be subtracting, multiplying, dividing, right? So just kind of pick the way that works for you. If your way was adding, like the top one, totally fine. If your way is the equivalent ratios on the bottom, totally fine. The equivalent ratios is my preferred one, so no worries.